Hi, you're talking with Brian Pruitt. I'm part of the RealSense business unit. I am the director of the peripheral segment. We are going to talk about the D400 series of cameras. The disclaimer, of course, that we do with everything. I'm not going to bore you by reading all of this. What we're going to talk today is we're going to discuss the importance of depth and why you'd want depth. Of course, our new series of products, the D400. We'll talk about how they can be used. We'll discuss the specifics of each device, the software that's available to you, and then our roadmap. What we're doing in the RealSense business unit is we're transforming or trying to reshape technology to give it the ability to see and understand us like we would understand it. This is our goal, and we are doing the first step of that with our D400 series of products. It's not our first series of depth cameras, but this is one of our best, and we are doing it to allow a product or a project to have vision. Let's talk about why depth is important. In this picture, you can see that we have several figures here. The idea with a 2D camera is how can you delineate how many pictures are here? Can you guess yourself how many people you see? 1, 2, 3? Well, as you see, there are 1, 2, 3, 4, 5, 6 people in this picture. What our depth camera allows us to do is to take that next level of information and provide you this feedback. So a 2D image can't do that, but a 3D image can. What this allows you to do is you can do things like scan a box and get the measurements. You can create a database of objects and have the camera actually recognize them. You could do object detection or collision avoidance. So a robot running around can avoid objects that are put in its way. It doesn't need to have a permanent idea of the path. It can just avoid them like we do naturally. Or you can tell a robot or a drone or any other device, I am looking for a phone, find me a phone, and it can look around the room and detect the object. And then, of course, the most common idea around 3D technology is the idea of 3D modeling. Taking a snapshot of a device or a picture of anything and making it a 3D picture. All of these things are things that 2D cameras can't do, and allows us to go this next generation of making a device smarter and being able to step us into this world of artificial intelligence. So how do we do this? Well, the first thing that we do is we have to capture what we call the RGBD data, the color camera data plus the depth data. We pass all this to our tools. So we have a visual processor that's aboard our device. This vision processor does all the calculations via a complex algorithm, passes the data to our SDK tools. These tools are just like any other SDK. We've made them so that it's very easy for a developer to go out there and understand what a depth is at a specific pixel, and then do whatever wonderful thing they can create with that. We've also realized that what a lot of coders do is they like to take sample codes and build on it. So we have put sample codes out there. All of our code is on GitHub. It's common for sharing. We like to open source everything. With this, we are allowing the community to help us grow. And then we, of course, do a lot of validation, and we try to improve the design over time. From there, you can take this depth information, put it in your device. You can take the depth and recreate a cup on your desk. You could use it to recreate a skeleton tracking application that you could use in medical, in rehabilitation, or in sports to determine if that football player has the optimum arm to throw the football 100 yards. So many uses. Over time, you can build these databases up. Then you could use AI to take that database of images that you have or depth data and improve it even further. Now that brings us to our actual products. I'm going to talk to you about our 400 series of cameras. Let's start off with the most basic component, but the most important component, the vision processor. The vision processor has 20 times the computational power of the previous generation. This is where we take all of the depth information from the algorithm and convert it into actual depths of each pixel. If you're an ODM that knows how to make these cameras, what you could do is you could use this processor in your design and not have to come up with the secret sauce of the depth calculation. The next step here is we have 5 modules. This is an expansion to the single module we had in the previous generation. Each module has a specific purpose, and they can be used for very broad usages to very focused usages. What we've done is we've broken them out into these 5 different types to allow you to pick the best type for your usage and get the best cost value. We'll start off with each of these being a stereoscopic camera. What that means is there are 2 imagers that take in the image. They work very much like your eyes would work. If you would take your thumb and extend your arm to arm's length, close your left eye, look at your thumb, then close your right eye, and then open your left eye and look at your thumb, you can see a shift in the vision. What happens is if you use mathematics, a great algorithm, you can determine depth to each point. This is what we do for every pixel that comes in from our camera. So stereoscopic, 2 imagers, and then we differentiate between an emitter and no emitter. No emitter is passive. Those are great for well-lit spaces with a lot of texture. If you're just in an environment that you're going to measure a box in a lighted place, this is probably a great solution for you. The next one, what we call our 410 solution, we add an emitter. What the emitter does is it shoots a bunch of dots over the surface to create an artificial texture. Think of the example I was showing you before, the white wall. Now, if you had to pick a point on that white wall, could you remember what point you're at? How do you tell the difference between another point on the white wall? What we do is we project a bunch of dots in a random pattern that allows you to see a artificial texture. This allows the imagers to know that the same point that the left is using, the right is using, and gives us an accurate depth. This also has an advantage in that if you have multiple cameras occupying the same visual space, the patterns would overlap, but that doesn't cause us any issue. It actually adds more texture. It's actually better for us. So you could have 3 or 4 or 5 cameras taking a picture of, let's say, every angle of a object that you're scanning, and the emitter would just overlay that and it wouldn't cause any issues. Very beneficial if you're doing like a 360 scan of something and you want to do it live and not have to move. So the 410, we've added that emitter to make that happen. The 415, we not only have the emitter and the 2 imagers, we have an RGB camera. It's very much like our previous generation, the R200. Those 3 cameras all are based on rolling shutters. What we've done in the next 2 cameras is we've taken the feedback from our customers where they are looking for a little bit wider field of view and maybe a faster shutter to handle high speed or low light conditions. With that, we have the 420 and the 430. It's an active and a passive solution, or I should say a passive and an active solution using the 400 series. The global shutter, again, it allows you to work better in a low light condition or high speed. The high speed, it prevents it from blurring. Think of a fast-moving robot or a fast-moving drone. you want to make sure that the dot that you see is really where you're at, that pixel, and not a blurred vision of it because the shutter wasn't fast enough. Those are the basics of or the basis of our building blocks of our cameras. We've also created the 415 and the 435 cameras. These are fully production-worthy cameras. These cameras take those parts and they put it inside of them. The 415 can emulate the 400, 410, and the 415 modules, and the 435 can emulate the 420 and 430 modules. What this means is a developer can take our camera, it can turn on and off the emitters, it can turn on and off the RGB, and they can go into the environment that they want to use the camera in and see what kind of images that the cameras are getting them. This allows them to rapidly prototype a device that they're coming up with or a piece of software that they're designing and make sure it works in the environment that they are in. Based on all of those pieces, we've given a wide variety of products that people can use from the very advanced person that's going to develop their own camera to the beginner or the company that doesn't want to do all the development, they just want an end device to make all of their products work. Each one of these designs. Our camera, our module, and our VPU make up this vision set of products that can provide you real-time accurate depth up to 36 million pixels per second. We can work in long range and indoors and outdoors. A lot of the depth camera solutions are limited by their lighting situation and they don't work outdoors. We're very modular. We have an open source SDK. If you want to design your own camera, you can take our parts. If you want the fully created camera, you have our camera. We are fully calibrated. We also allow you to calibrate the camera. This is something that the other camera makers don't bring up, is all cameras need to be calibrated. And we give you the capability not only calibrating it at the launch, but also you can calibrate it if you have an accident with your camera, like you dropped it from 10 feet, or you set it in the Arizona sun and it got up to 150 degrees in your car. All these things we give you tools to do. Our form factor is very small, allowing you to fit us in places that where previously we couldn't have. And of course, the vision processor itself is a it's a low power and high performance computation device that gives you all of this onboard computation, allowing for a lower powered CPU to do all of the other work. Here's a breakout of the complexity, the design time, the pricing it would take to use our three different solutions. Of course, we have the VPU, the module, and the VPU in the camera. And it makes sense that at the VPU level, it's going to take you more time to design. It'll take longer to get to market. It's easier to get more volume, and it's going to be a lower cost to start there. For those that are ready to go to market today, don't want to spend the time on the R&D to go from a bare silicon solution. We have the camera, which is production ready, and then in between is the module and the ASIC card itself. What we've done here is we went from a R200 generation to this D400 series. This gives you some idea of the increase in our specs. You can find all this information at realsense.intel.com. On that website, we've put all of our documentations, we've put our CAD drawings, we've put our product brief sheets, we've put our use cases, our software. Everything can be found at realsense.intel.com. I will probably say that several times during this presentation, but please take a look. A great example of our 400 series is we've increased that range out to 10 meters. It's down to about, you probably get down to close to 10 centimeters to 10 meters out there. It's going to, of course, your accuracy, the further out that you get, it's going to be less. We have a sweet spot about 3 to 4 meters or 2 to 4 meters, and that's about 2% accuracy. You can also see our depth runs at 30 frames per second at 720p, or you can go down to 480 and get 90 frames per second. 85-degree field of view, that's our wide field of view. The dimensions are very small, and everything comes with our new RealSense SDK that we are constantly updating. If I focus on our two cameras, let me show you why we think they're amazing. If you look at the scenes of the pictures on this slide, you see an outside scene and you see an inside scene. We use our previous generation and shot that scene in depth, the R200. The black represents unresolved depth, or we did not know what the depth was at that point. Now, if you move to the D400 series, the whole thing is all filled in with depth. Even the outside scene, you can take some guess that some of those images are past 10 meters, and we still see those images. This is what we love about our new camera. This computation from the VPU just gives us so much more depth data, allowing the end user or the developer here to take that depth data and do something amazing with it. The frame rates up to 90 frames per second allows a quick data feedback for high-speed moving objects. And the standard or wide field of view can meet the needs of whatever use case that you have. And I don't want to underplay. I want to actually overplay the sunlight and outdoor environments work great for our camera. So indoors, outdoors, you don't have to be finicky with the lights. Our camera works great in both environments. Let's talk about the two different cameras. I know I've touched upon it, but there are some slight differences between the 415 and 435. The first one being the field of view. The 415 is about a 70-degree field of view compared to about the 90-degree field of view of 435. Think of the different applications where a wider field of view would be in. I've mentioned them already, like robotics or drones or full body scanning. The wider field of view is just going to be easier to get more of the person or object into that camera in one shot. The other part is the rolling shutter versus a global shutter. And again, we've talked about this. Navigating spaces or with the lights off, it's better with a global shutter. The other difference that I haven't talked about is the 415 is about a $149 price point and the 435 is a $179 price point. Remember when I was talking about how the modules can be emulated by the cameras? Here is exactly what I was talking about. The 400, 410, and 415, the 415 camera can make, it can have the same response as a 400, 410, and 415 modules. In our SDK, you can turn off the emitter, you can turn off the RGB, and that way you can see maybe that your solution can use a less expensive camera like the 400 to build your product. Likewise, the 435 emulates the 420 and 430, and those two you can turn on and off the emitter. This just is a quicker way to do prototyping and a faster path to productization, allowing you to take a camera that is fully ready and see if you want to go the module route, and it allows you to pick the right module. We also take our camera and we box it two different ways. One is the traditional boxed camera. You put it in a pretty box with the camera and the cable and a tripod, and you sell them individually. These are great for your enthusiasts, your developers, even academia. It's a great way to get a single camera out there to start having somebody play with depth. The other way is we understand that some companies are going to take this camera and they're going to actually productize it into their solution. What we wanted to do is offer them a lower price and a better way of getting multiple cameras. What we've done is we put them in packs of 30, or we call them bundled cameras. and we sell them at a lower price than what we do the box camera. The difference between the two solutions is we are only putting the camera itself in that bundled box. So that box of 30 is just a camera. You'll have to go out and source your cable. You're not going to get a tripod. You're not going to get the nice box. It's just in a cardboard box that's segregated, and you can get a better price to pass that savings along or to increase your profit margin if you're going to embed into a design. I've talked a lot about the hardware. The other important piece to make this all work is the software. Intel's developed what we call the Cross-Platform SDK 2.0. It's the second generation of our current SDK. What we've done is we've focused solely on depth, on providing you the easiest and best depth information possible. And we wanted to do it not only on one platform or two platforms. We wanted to make it available to the most familiar platforms for developers out there today. Example, we go across Windows, Linux, Mac OS, and even Android. Not only do we do that, we're also putting it in the most popular wrappers. Things like Unity or OpenNI or ROS or Python. These are great wrappers that programmers use every day by the millions, and now you can program in your language and get access to this depth. On top of that, we've talked about the examples before. There are examples like point clouds or multi-camera capture. All of these examples are available on our website, our GitHub. It's a great place to go and interact with your fellow developers to make something wonderful. Let me talk to you about a couple of, or actually the Intel RealSense viewer. To me, this is the most important tool that you can use to see how well depth is working. First thing that you need to do is you download the viewer. Remember that realsense.intel.com. If you go there, look under SDK or download tools and look for the Intel RealSense viewer, you can download it. It's a whopping 10 megabytes. It'll probably take you seconds unless you have a really crappy internet connection. You start this viewer with your camera plugged into the USB and you get what I'm showing you on the screen. Some things I want you to know is it verifies what type of camera you have. It tells you when you're plugged in. You can see on the arrow there. The second thing down is if you want to understand what firmware you have, we are constantly updating our camera. We do an agile programming method to do all the designs, so we are going to see, you probably see a lot of rapid changes over every few weeks. So you can look at your firmware and see if it needs to be updated by clicking this info button. It gives you other information, but this is one of the places where you can find out what the firmware is. Then the pull down allows you to do presets. What does this preset mean? So if you think about a camera, say you bought an expensive Nikon camera that's worth thousands of dollars, it has plenty of settings that you can do. I'm not a photographer, so I'm not going to pretend to go over each one of them. But you have aperture and speed of the shutter and lighting and all of these different settings. You have the same thing with our cameras. We have over 40 different ones that you can adjust to get different levels of depth information back based on your environment. So if you're a pro at this, you can go into our advanced settings and start messing around with all these settings to try to get a better picture. We understand that a lot of people don't have the knowledge or they don't want to do that. So what we've done is we've taken our brilliant PhDs, locked them in a room, and told them they can only come out if they come up with great presets. Well, okay, we do let them out more than just for great presets. But what we do is we put these presets here in this table, and this will constantly grow. Some of them will be like best accuracy, some of them will be focused on hands, some of them will be focused on best density, and what that allows you to do is you can look at the preset that we defined for that camera and see if it works in the environment that you're trying for. Maybe you need to be very, very accurate. You want every pixel to be 100% what that depth is. Or maybe you want to see no holes. So what you're going to do is you're going to use a more loose algorithm factoring to figure out what the depth is on the pixels next to the one pixel that you have a great depth for. In any case, these presets allow you to check the camera in different environments. Lastly, you have two switches there, one to turn on the RGB and one to turn on the depth cameras. Very important. If we move on to what it actually looks like, so now you've turned on your cameras and you get a depth view. That's the multicolor view. There's actually a gauge on the side to tell you what each color means depth-wise, 1 meter, 2 meter, 3 meters. You get the RGB view. You can see in my picture I have a Starbucks cup. I may have a Starbucks bad habit here, but that makes for a great picture. And then on the bottom left, it's a little hard to see. What the bottom left is actually a picture from one of the imagers, one of the sensors. And if you can really blow it up, if you can really look at it, on the cup itself, you can kind of see these tiny dots. This is from the emitter. This is what the actual camera is seeing, that allowing it to have texture, and that's why you're getting good texture on like that back wall. That back wall is like an all-white back wall, and you can see the red going into yellow for the back wall because of the camera angle that I have, but that's because I have texture. And then lastly, the great part of this, creating a 3D point cloud. This is what most people understand. There is a setting that you click in the upper right-hand corner. I didn't point it out quite here, but it's in the upper right-hand corner. It says 2D and 3D. You click 3D, and what it does is you can choose, first of all, what your reference point is, meaning I have the 3D data. Do I want to add color on top of it, or do I want to add that image or vision? I always select RGB here, so I can put color on top of my depth image, and I can get the picture that I'm seeing. The second part is you can rotate your point of view around. So the camera has one point of view. Now I can take my mouse and I can rotate it. It's hard to see in this picture, but there is a blue line that's pointing towards the right side of the picture. That is the direction the camera is facing. Now I've actually turned it so I can look at the right side as if I actually walked around the object. So my point of view is different, and it shows the information. The black shadow behind that cup, what that is the inclusion by the cup, meaning my infrared or my imaging, I'm not getting any data back behind it because the cup's in the way of getting the data. This 3D picture, or this 3D point cloud, and this viewer in general is the quickest way to show somebody how well our depth works and what depth truly is. We use this in all of our demos and all of our events. We take this to all of our customers because it's easy to understand. Here's depth, and it's a quick way of knowing that your camera works. So I was talking about the tools, and this is just a brief slide to remind you of these tools. Again, go to realsense.intel.com, look under the SDK or the downloads and tools, and you'll see what I'm talking about. The viewer, we just covered several slides on what it was and how to use it. We also have a depth quality tool. This is to test how well your camera is performing. If you have questions that your camera may not be as accurate as it could be, you can run this tool to figure it out. We also have other debug tools that we could use, the data collection, a firmware logger. We can do terminal access and camera enumeration. All these allow us to help you troubleshoot the problem if there's any issues. One part of software that I haven't discussed, but we are looking at expanding our current sets, is what we call middleware. In previous generations, we did things like gesture tracking or skeletal tracking or object recognition. In this generation, we chose to focus on depth, like I said earlier. Instead, what we are doing now is we are looking for partners out there that are interested in taking our camera and doing things like skeletal tracking. And here's a great example. We have started working with a company called 3Divi. 3Divi, we are very close to closing agreement, which allows us to provide skeletal tracking via the D400 series of products. This is very important. Think of the Microsoft Connect. They had this capability, and we are emulating it right now with this company. Of course, we'll charge, or the company themselves will charge some amount for the licensing, but our idea here is to not stop at skeletal tracking, but look at all these middleware pieces that can add another depth to our camera to make it easier for developers out there to go from just coding to doing something amazing with the pieces that we've already provided. This is the other reason why we are on GitHub. We want to create this healthy open source community and encourage people to say, hey, I have this object recognition software that I developed for D400, and then have people iterate on that and then have an amazing piece of open source software. This is the future of any of our coding, and we believe it is the best way of making our camera easy to use by everyone out there. No presentation would be complete without a technology roadmap. So I've talked about the hardware itself, and now I've talked about the software, and now I want to talk to you about our roadmap. So if you look our previous generations, this is our sixth camera, our second generation of stereoscopic camera. We have the L200 and the ZR300 that we have just stopped doing, and we're now into the D400 series. The D4 and D4M, these are VPUs, or the vision processors. All of the modules you see on the module line, and then the 415. We plan to have these last about a 3-year life cycle is what we're thinking. Where we think the handoff's going to be is roughly in 2020 when we start developing or releasing our next generation of stereoscopic cameras. The great news is we plan on making our software compatible or backwards compatible. So if you've designed on the D400 series, you should very seamlessly or very low touch be able to move from the D400 series to the D600 series and get a better result because the technology is going to be better. This way, we can keep generation to generation. We keep the customers without them having to redo all of their coding as in with our previous generations. Lastly, as I out here, is the product brief sheets. I'm not going to cover everything on this sheet, but these are the spec data that most people want to see right off the bat to see if the cameras will meet their need. The D415 and the D435 taken straight from our RealSense.intel.com site. This is the best site for the information that we have on the camera, and we will constantly update this site. I want to thank you for your time today. Please feel free to go to this RealSense.intel.com site. I look forward to you trying out our camera, and I hope it's everything that to you as it is to us. Thank you. Now that we went through all the material, I'm sure you have questions. So let's take the next 15 minutes and answer those questions. Hi, this is Brian Pruitt. I thought I would answer a few of the questions that are seeing out there. I've answered some of them, but I wanted to keep answering them, and please keep typing in your questions if you have any. Let's start off with how stable are the SDK and wrappers? Are they production ready? And the answer to that is yes, they are production ready. We are doing agile programming, which means we're probably updating them every 2 to 3 weeks. We're doing some fine tuning, especially check out our firmware this early in the stage as we add more capabilities in there. What camera do you recommend for indoor 3D reconstruction? You know, the great thing about our cameras is they work perfectly indoors or outdoors. For your indoor reconstruction, if you're talking about a specific object that you're reconstructing, the 415 is a great camera for you. If you're talking that you need a wider field of view, like you're going to try to reconstruct a whole room, the 435 is probably a better one because you'll get more data in. Take a look on our website. We do blogs, and we're putting a blog up soon about what's the difference between the 415 and 435. So it will help you make your choice moving forward. But check out that realsense.intel.com. We put a ton of information up there. It's a little bit different than our normal website. What we're trying to do is get all the documentation in one place for you. So you'll go to this site and you'll go to GitHub, and you should never have to go anyplace else. Does 435 lose calibration more easily if attached to a robot that is bumping into the thing? Will it lose accuracy? It's a great question. The 435, the difference between, one of the internal differences between the 415 and the 435 is the 415 has everything on one stiffener. It's all on one module, meaning the RGB, the imagers, and the emitter are all on the same material. The 435, what we've done is we've mounted the RGB camera to a 430 module, so they're actually not attached, but inside the camera we have securely mounted it. So unless the robot is banging into things, like maybe at top speed, it shouldn't be an issue. We do drop tests to make sure that it doesn't go out of calibration. But even if it did, we have software that will be available that you can just quickly recalibrate it. Slides, what we try to do, I don't think I'm going to make slides available, but I'll check. What we do have available is we do put all of this information, again, towards our realsense.intel.com. Take a look at the download tools. There's even more information than what we have here. We have everything from CAD drawings to white papers on how to use multiple cameras to methodology of calibrating cameras to blogs on people using our technology. Please take a look there. You'll find out all that you need. For face tracking, we focus on, as I was saying earlier, we were focusing on depth. So what we try to do with this series of camera, unlike our previous series, is we've provided depth across a number of operating systems and a number of wrappers. The next thing that we're looking at is middleware. We call things like face tracking and skeletal tracking middleware. I talked briefly about skeletal tracking. What we're doing is we're going out and looking through our community, people like yourself, and we're also looking for third-party ISVs that want to partner with us, that show they have a product that they would like to show us, and maybe we can co-market with them. The idea here is we want those companies that believe in this product to show us their face tracking, and we will maybe put it on our website and say, look, everybody go here to get face tracking. But we don't have a face tracking piece right now. But we do believe that 3D is the way to improve this. Apple used it in their iPhone. I think that's a great use of 3D. There's other uses out there. Take a look. Is there a preferred vendor for high volume sales of cameras and modules? Intel we have a whole list of distributors that do high volume sales. You can search for Intel authorized distributor, contact any of them in your region, wherever your region is, and they will be able to purchase cameras. If you have any issue, you can go to our website, again, realsense.intel.com, click buy, and we have a few listed right there that you can go to. Once you've connected the USB to the compute device, does the RealSense software give me all the depth information detailed in centimeters? It does in meters. So what we do is you have to have the SDK, so you would plug this into your compute device, run our SDK, and the quickest way to see if it's working is use the viewer. It's a 10 megabit program that runs. It comes with the SDK. You start it up, and it does it in meters and points of meters. Have you tried higher resolution? We have. our cameras actually support higher resolutions, but this is the resolution we've chosen right now for the frame rate to not overtax the amount of data that we're putting on. So right now we're sticking with 1280 to 720. That doesn't mean in the future we won't go higher or faster. How do I compare our camera against the Z camera? What I would suggest you do is purchase them both, and you tell me what you think, because my answer is going to be obvious. Does changing depth resolution affect range or accuracy? Yes, it does actually. Think of bigger pixels. So if you are trying to see a scene and that scene is made up of pixels and you want a precise point on that scene, your pixel size is important to make sure that that exact spot is where you want. So the more pixels, the better accuracy you're going to get. But it depends on how much accuracy you need. I mean, are you talking less than a millimeter or more than a centimeter or two? In most cases, it won't affect you enough that it's going to hurt using a lower resolution. Distributor that sells D400 the same or less. Yeah, just take a look. Take a look through the different ones. We don't talk about pricing, but you can look at our site and see. Do you have a sample project on how you realize the volumetric video capture case? I'll look into seeing if we can put some sample code up on volumetric capture. The short answer is right now we don't, but we are always updating. Ubuntu Mate 16.04. We support Ubuntu 16.04. I don't know what Ubuntu Mate is. I'll ask, and if I will send an email if it's different than regular Ubuntu. When using D435, the min distance is decreased at lower resolution, around 30 centimeters distance, but need to do 848 by 480 to get 20 centimeters. Reduce resolution. It's about the smallest that you're going to get based on our baseline. So the real distance here is, the real issue here is the amount of distance between the two imagers. 20 centimeters to 30 centimeters, it's roughly, it should be about the same. I'll find out why you're seeing a difference of 10 centimeters between the two resolutions there, but it's all a difference between the baselines. The wider the baseline, the further out you can go. We've run models and we've done proof of concepts where we had over 130 centimeters or millimeters. Sorry, we're using 50 and 55 right now between the two products. We've doubled that, tripled that, and we've gotten out, much further distances. That's an amazing thing about our VPU. It's very versatile in the fact that the algorithm works no matter what baseline you'd use. You just need to tell it what it is. What single computer boards do you recommend with RealSense camera for the purpose of SLAM? We've had a lot of luck with mini vendors. One that we've worked with in the past, we actually made a robotic dev kit in our previous generation with our R200 with Aeon. We think that they know our product really well. But almost any compute board that will do what you want should be able to handle it. We test our cameras with the operating systems and the wrappers, not necessarily the SoC. So if it runs that operating system, you should get it to work. So go find your favorite single board maker, whatever processor they use. Of course, I'm hoping that you choose an Intel processor, but it should work with almost any USB 3 capable single computer board, and Aeon is one of the ones we've used in the past. Is there a guideline on how to tune parameters? It's amazing that this question came up. I was just sitting with our Chief Technology Officer for RealSense, and he has a white paper that he's going to publish. It'll probably be out in about a week. And really what it is it's how to further tune the camera. So it's exactly what you're asking. So check on that website I keep talking about, and it should be up in the matter of maybe by the end of this week. What's the current shipping date? Wow, I knew this question was going to come up. So the 415 and 435, these are lead devices to help developers. So you grab these cameras, you take them, you make whatever you think is amazing, and then you can either build them into your product or you can build modules around it. So what we didn't anticipate is the amount of demand that we would have. So the demand has been so high that it's outstripped our supply. We've increased our supply. So for the D415, it's down to about 2 to 3 weeks if you ordered it today. In a few weeks, there will be no wait. When you order it, there should be supply and demand. Now, the D435 is a different story. A few more customized parts inside of that one. So that one's still about 2 months from the time you order it. If you ordered it today, it would be roughly 2 months before you would see it. That's going to improve very quickly. What we will do is tell our partners as this gets better. I know that's not the best story, but it's why we're putting out a paper of the differences between the 415 and 435, because I believe most people could start with the 415 and then maybe later go to the 435 for testing. Shield cable needed for high EMI environments. We haven't really tested in high EMI environments, but if it's going to interfere with the data going across, if you're sending a lot of the data, I would say yes. But right now we don't even use a high shielded one for us, and we do a lot of these in the lab. I was just watching our CTO do it with 4 cameras at the same time with the USB cables, just standard USB cables with a Type-C connector, all intertwined with each other. There was no issues there. It would be tests. That's what I would say. Grab a USB cable and test it in the environment. That's the great thing about having those cameras. You ordered a 420 module on a D4 compute board and it doesn't compare the cable that connect together. Is the flex cable available? I would reach back to Mouser. They should be able to help you with this. If not, we have a community section inside of our website. Click on that community and there's a place that says ask a question. That is monitored by our actual developers of the technology and the software developers. So this is going to be the quickest way to get to somebody that actually designed this technology to get your help. I think that's all the questions. I think we went through them all. Any more? Well, I want to personally thank each of you for submitting all these great questions and listening to the entire webinar. Feel free to visit us on our website. We update it a lot. I know I've said that many times. It's very different than a lot of the other areas at Intel. We are hoping to build a strong community there, and I'm hoping you get these cameras and enjoying the product. Are you planning to update RealSense samples that you created for the ODE SDK? Yes, we will. For the old SDK, RealSense samples that you created. I'm assuming you are talking about. I'll look this up. Yes, the short answer should be yes. We'll eventually update it. We won't. I'm sorry. We're not going to take the stuff that was in the SDK 1.0 and move it forward to the SDK 2.0. Two separate technologies. We're not going to take the time that it would take to deconstruct and rebuild them. We're more focused on making what we have better today. And hopefully we'll find partners that will help us recreate those samples. We do have a hardware sync across the 435 units, and read that 435, or read the multiple, or read the white paper that we have on multiple cameras. It'll tell you how to do it. Fantastic. I think that are all the questions. So you all have a good evening or a good morning, depending where you're at in the world, and thank you for your time.